We are now continuing with the final exam review, working through these final exam review problems. We're ready for number 17, and on number 17, we are going back and forth between polar equations and rectangular equations. Polar equations will have r and theta in them. And don't think of this, maybe I shouldn't put the parentheses here. You're going to have an equation with either or both r and theta, and a rectangular equation is an equation with either x and or y. These aren't that hard. It's almost just like you just have to know, I don't know, I want to use the word tricks, but you have to know how to work these out. They're not that hard. For the first one, here's an equation of a graph. It's a polar equation because it's r. And I don't know, what would this be like in a rectangular equation, which means it's going to have an x and a y. Now, just like with polar coordinates, as a review, the equations that relate polar coordinates and rectangular coordinates, here's one for the radius, an x and y. If you remember, tangent of theta, the angle, is y over x. If we go the other way, we know that x equals r cosine theta and y equals r sine theta. So now here's the tricks. For this one, this is where you just sort of have to know what to do. It's not totally obvious. So you have r equals 7. What I'm going to do is I'm going to square both sides of this equation, which we can do in math, as long as you do the same thing to both sides. R squared equals 49. And now I gotta use this equation where I know r squared equals x squared plus y squared. Now hopefully you remember an equation like this is a circle with the center at 0, 0 at the origin, and the radius is the square root of this number here. So here's my equation, the first part of the question, and then they ask for the graph. And you notice they're asking for a graph, and it's sort of like polar coordinates. So you just, this one is a straight line, this one's a vertical line. Here's a circle, center at the origin, so C and D are circles, and you just have to figure out which one has a radius of 7. That's going to be C. Alright, that wasn't too bad. So 18 is another problem going back and forth between polar equations and rectangular equations. And this one, we're told this is an actual equation. You could actually go on some graph paper, and actually we could do it if we had some polar graph paper. The angle theta is pi over 6 Where's pi over 6 if this is 0? Pi over 6 is here. My guess is this is going to be a straight line. But now, they want this equation in rectangular coordinates. Now for this kind, when they give you the angle, we use the fact that the tangent of the angle in polar coordinates equals y over x. So since theta is pi over 6, we can say tangent pi over 6 equals y over x. Now we know tangent of pi over 6, tangent is like sine over cosine. Sine of pi over 6 is 1/2. Cosine of pi over 6 is square root of 3 over 2. Or if we want to rewrite this, we rationalize the denominator. So bottom line is now we've determined y over x equals square root of 3 over 3. But normally when we write an equation, it's y equals something. So I can multiply both sides by x. So this equation is y equals square root of 3 over 3 times x. This actually is the equation of a straight line. Turns out we have a slope of square root of 3 over 3. So that's the equation. And then you'll notice they ask for the second part, what is the graph of this equation? And it talks about line going through quadrants. Of course, obviously, looks like it goes through quadrants 1 and 3. Looks like this down here, which is also answer B up here, line in quadrants 1 and 3. All right, not too difficult. However, another one. Now here's one where we have both r and theta, the same equation, and once again we want to write this equation in rectangular coordinates. Now this you have to remember, r sine theta when I wrote down a few minutes ago those relationships between r and theta and x and y, one of them was, we know y equals r sine theta. What do we have here? R sine theta. So that one's pretty simple. What is y equals 7? Y equals 7 is the horizontal line that goes through y equals 7. All right, now number 20. Next sort of topic. It says plot the complex number in the complex plane and write it in polar form. So here they give me a number, sort of a funky number, 2 square root of 3. All right, so now we're given complex number. Now, complex number, normally we write it, we're going to start graphing complex numbers. X we call the real axis, Y we call the complex. So if the number's written like this, you plot the x value on the real axis and the y on the complex, and you get a point. For instance, well, in a minute, we're going to do this point. But at the same time, we did a thing where we can also convert these rectangular coordinates into polar, and we can sort of turn this real complex graph into polar coordinates. And for that, it's going to be r times, in parentheses, cosine theta plus I sine theta. Here's r and theta, here's x and y, and really all those same relationships with polar and rectangular coordinates apply. So let's do this one. First of all, let's go plot this, and then they want us to rewrite this in polar coordinates. So in a sense, what I have is my x is like 2 times square root of 3. Now this is just going to be a number. Let me see what that is. 2 times the square root of 3 is like around 3.5. So really this is 3.5 plus 2i. So 3.5 is maybe around here on the real number, and then 2i is up here. So that right there is this point, and I plotted it in return coordinates. Now they want me to rewrite this in polar coordinates. So I need to get r and theta to do that, and the same rules still apply. R squared or if I want to, I could just say r is the square root of x squared plus y squared. X squared 2 square root of 3 squared plus y squared is the 2 squared. So this is going to be, if you square the 2, it's 4. If you square the square root of 3, it's 3. So it's already 4 times 3. So it's already 12. 12 plus 4 is 16. Looks like r is going to be 4. Now let's figure out theta. Tangent of theta equals y over x. Y is 2 and x is 2 square root of 3. So we're asking, is there an angle that when we take the tangent it equals 1 over the square root of 3, or a lot of times it's easiest to remember a tangent sine over cosine. Now we hopefully have done unit circle long enough that you realize that there's this point where the cosine square root of 3 over 2 and the sine's 1/2, because 1/2 divided by square root of 3 over 2 is 1 over square root of 3. What angle is the sine 1/2 and is the cosine square root of 3 over 2? Actually, if we do it in degrees, that happens at 30 degrees. So really, now that I got my theta, here is the rectangular complex number, but written in polar form, it's r, which has 4, cosine of 30 degrees plus I sine 30 degrees. So there is the complex number written as a polar equation. All right. Looks like we have maybe a few more of these. Number 21. Once again, you can always print these out or look at them on your computer as we're working these. 21 says, plot the complex number in the complex plane and write it in polar form. So same thing. So here the number is negative 9i. In other words, normally it's x plus yi. It looks like the x part's 0. All we have is the complex part. So if I try and graph this, negative 9 in the complex plane means I go down 9, and it's right here. So now the question is, what would this be in polar coordinates? Actually, I don't even really need to do any math for this one. I need to get r and theta. R, right, would be that distance, which is pretty obviously 9. And theta is this angle. And in this problem, it looks like they're looking for the answer in degrees again. What is this angle? 270 degrees. So minus 9i equals r. Remember, here's the equation for a complex number in polar coordinates. R times cosine theta plus I sine theta. R is 9. Cosine theta, cosine 270 degrees plus I sine 270 degrees. All right, now we go the other direction. They give us a complex number written in polar coordinates, 10 cosine of 4 pi over 3 plus I sine 4 pi over 3. And they want us to know what is this in rectangular coordinates. Well, this is actually pretty simple because, of course, this is my r, and there's my theta. We have these equations, x equals r cosine theta, y equals r sine theta. It's like 10 times cosine of 4 pi over 3, unit circle, 4 pi over 3, cosine, I believe is 1/2. For the y, 10 times sine of 4 pi over 3. Although actually, you know what? I should think about this. You know where 4 pi over 3 is? It's right here. So this thing is going to be negative. And we know the sine of 4 pi over 3 is also negative. So sine of 4 pi over 3, square root of 3 over 2. Looks like x is negative 5. Y is negative 5 square root of 3. So therefore, to write this as a write this complex number in rectangular coordinates. -5 minus 5 square root of 3 times I. Alright, so these aren't too bad. You just have to remember the key is using, once again, these definitions. Going back and forth between polar coordinates and rectangular coordinates. Actually, looks like we have one more. So here's the complex number in polar coordinates. Once again, I go back into my notes where I wrote down, this is a complex number written in polar coordinates, right? R is out front, cosine theta plus I sine theta. It's like theta is pi over 2. If we plot this real quick, pi over 2 is right here, and 5, so this point's right about here. So now, to do the actual math, x is r cosine theta, r is 5 cosine pi over 2. What's the cosine of pi over 2? It's actually 0. 0 times 5 is 0. So actually x is 0. Y is r sine of theta. R is 5. Sine of pi over 2. What's sine of pi over 2? It's 1. So it looks like this whole number, there's no real part because x is 0. All we have is the complex part. Alright, I'm going to stop now. The next video, we're going to start looking at vectors. Sort of a new topic. So I think now's a good time to stop, and we'll continue with the next video.